We're going to drop right angles for 3 weeks. We'll get back to them and talk about circles and ellipses. Now, between right angles, squares and cubes, and circles and ellipses, would you guess which one is simpler? Somebody said ellipses. Who else wants to add to or subtract from that? Which one is simpler to understand? I'm getting several people saying circles and ellipses. Between right angles and circles and ellipses.
Right angles?
Right angles are simpler. I will state this emphatically. I know it seems like circles and ellipses are simpler, but it is a deceptive thing that comes from the fact that you are more attracted to round and curved shapes because they're friendlier. They're more huggable. But when you compare something like this that has 6 planes, and no more than 6 planes, actually 3 planes, but each one of them has a top and bottom, or a left side and a right side, or a front and a back. 3 planes pulled apart into 6 planes. How many planes does this have? What? For practical purposes, an infinite number of planes. Say, well, why should that be important for drawing? Because if you stick a pin through this, or stick pencils into this at different angles, do you realize that you can stick 100 of them in there and every one of them is going to be a different plane? And that if you want to draw that, you've got to know exactly what kind of plane, and you have to have some kind of number for it or something, and that you get lots of numbers. Circles, which make ellipses, which make cylinders, which make cones, and which can make spheres, are almost infinitely complex. They seem that way when you start to dissect them, when you start to analyze them. But of course, we will find a way to simplify them. When we've talked about right angles, we've talked about squares, which can then turn into cubes. Cubes, not just blocks. Blocks can be rectangular solids of differing shapes. But here is one of the ways that you simplify the problem of circles, which become cylinders and cones and spheres. Remember that a perfect square will house a perfect circle which will hit on 4 points. That's the way you'll simplify understanding a circle. Is that you've got these, remember, you've got 3 directions. This direction, that direction, and then the direction that goes off into space. And likewise, if you are able to build a perfect cube, a perfect sphere will fit in there, and you'll be able to find hidden areas on that sphere. But I'm not going to talk about that tonight. I'm going to talk about that next week, because that starts to get more complicated than what I'm going to talk about tonight. I just wanted to let you know there is a relationship between circles and squares, and therefore spheres and blocks, cylinders and blocks. Now, when you are looking at an untrained artist's work, if you could divide the world into the untrained and the trained, which it's not that simple, because you can be trained in some areas and deficient in others. But let's say that there's the trained and the untrained, just like they had Goofus and Gallant in Highlights magazines, and Goofus was bad and Gallant was good, to try to make a point by contrast. The trained and the untrained artist, there are certain giveaways in the work of an untrained artist where you can look at it and know right away that person is not trained. One of the ways is by how the artist handles edges. Another way is by how the artist handles form and the ability to understand form. But let me tell you one of the ways that for me has become the quickest. It didn't used to be, but when I got trained in how to do ellipses, I can look at any drawing, and if it has anything in it that is like a wheel on a car, or not just a wheel on a car, if there's somebody just drinking out of a cup, if there's someone that's got a cup in their hand, or on the table, or if there's a gun that has a gun barrel in it that's pointing any direction except straight at you or perfect profile, or if there's an airplane that has a propeller on it that's spinning, or better yet, a helicopter with a spinning propeller, or a clock, like so, I can tell that fast. I can look at it that fast, say that person is trained or untrained. Because one of the quickest giveaways of a lack of training is the inability to handle circles when they are tipped into perspective, which become ellipses. So if you're listening to this and you're thinking, gosh, I don't want people to look at my stuff and know that I'm untrained, remedy number one. There are many remedies, and in fact the next 3 lectures are going to be about remedies having to do with circles and ellipses. But the first remedy, the first thing you have to understand in order to draw a propeller on a helicopter and get it right, since it goes in a circle, is you have to understand how an ellipse is constructed. They have a definite construction, and it does not vary except in certain instances like distorted photography. But if you have what is supposed to be a perfect circle, and you tip that circle, I used to use the analogy of long play records because, you know, those of you who are under the age of about 23 might not know what long play records are, but they were a big part of our life. CDs have replaced them, but CDs aren't quite as good for the analogy, which you'll see, partly because they're smaller. But you know, records, they used to be this big and they were made out of black vinyl. There was even a store called Licorice Pizza, which was a reference to black vinyl. What? Laser discs, okay. But even those aren't going to make part of the point that I want to make. There's 3-dimensionality to a vinyl record. Okay, if you tilt this record in space, it looks a certain way, and we call that look an ellipse. An ellipse is not an oval. What is an oval? An oval is an egg shape. An ellipse, and I'm going to use about 30-degree ellipses. These are probably 30, 25-degree ellipses through this lecture to make this point. An ellipse, for one thing, is perfectly symmetrical, left to right, top to bottom. An ellipse is not shaped like this, nor is an ellipse shaped like this, which you'll often see people draw it that way. They are constructed symmetrically both ways, and the best way to construct an ellipse is to use those crosshairs. That is, if you've got this right angle going on, and this is just for constructing. We're going to have some complications come in here when we try to find the middle point on that record and find that it's back there when we tilt it. But for construction purposes, that distance must be the same as that distance must be the same as that distance. And then you can start working this out so that it's going to be perfectly symmetrical. And the way you do that is if you're on a desert island and you've got to construct an ellipse, there is a way to do this. I don't know whether I ought to bother to take the time to do it here. I will after the lecture if you need. There's a way you can take a piece of paper, measure that, and then start one way, and you can pull this down and make a perfect quarter of an ellipse with a piece of paper with tick marks on it. And you'll get just the right curve. And you can make you can make it as open an ellipse as you want. And if you get 1/4 of it, you can get the whole thing, right? Because you'll just then transfer this corner to that, and that will be, turn the tracing paper over, if that's the way you're doing it, transfer that way, and then take that whole side and transfer it over there. There's another way to construct ellipses. This is the way everybody used to do it a while ago. These are called templates. Have you seen these things? You need templates if you needed templates at one time. Now you don't need them so much. Templates are expensive. I remember John Dickinson lived in Anaheim, and we used to be on deadlines all the time, and somebody would call somebody else at 1 in the morning and say, do you have a 35-degree one that's 4 inches? I need a 15 1-degree that's 4 1/4 inches. They're expensive. I'd go out and buy a set of ellipses. I spend $150 like that for a set of ellipses. But you don't need templates anymore. What do you do now if you want a perfect ellipse in the last few years? What do you do? Yeah, if you have Illustrator or Quark Express or even Photoshop, which isn't even a drawing program, it's a painting program, you can construct any size or shape ellipse, and it will be perfect, and it'll print out on your printer perfectly. But if you're on a desert island and you don't have your computer with you, it's nice to know how to construct one out of paper. But there's another way that you should construct ellipses for most drawing. I mean, you've got to do this kind of stuff if you're doing architecture. But if you're doing stuff like somebody's wearing glasses and you're sketching them in and they're round glasses, there's a way you've got to do ellipses, and it's called freehand. People don't know anymore, do they? The way you learn to draw good freehand ellipses is, first of all, this is the way I learned to do it. This is an ellipse template, by the way, not a circle template. You'll find out why in about 3 minutes. You look at these and you draw the crosshairs. You draw verticals and horizontals at right angles, and then you fit these on there and you draw them and you take sections of them and you meditate on them. You look at them and memorize this curve and how it gets more severe, and you memorize that curve. Do you remember how, if you ever fell in love, do you remember how you could close your eyes at night and you could actually see your beloved's face? It may not be that kind of emotional rush to do this, but it's the same thing that's got to go on in your intellect and your imagination. You've got to be able to close your eyes and see this curve and all the different variations of it. And when you do that, then you can just throw in a quick freehand ellipse, which won't be accurate unless you're amazing. And you'll say, okay. And you say, that part's correct, because I'm right-handed and I got the curve just right. And then you can take that and sort of bend the other stuff to make it fit. And you can fix that freehand. You also need to get those crosshairs in your imagination too. But there is a specific construction to ellipses if they are perfect circles. Perfect circle is an absolute thing. It is not open to interpretation. There's a point and there's a line, and the line stays in constant relationship to that point. When you tip it in space, there's a definite construction. And it's not open to interpretation until you've done it, and then you want to interpret it, you can start screwing around with it. But first you've got to know what it looks like. Now, if you know how to construct one, that's the first remedy of becoming a trained artist, because there's circles everywhere. But then there's another question that comes up. I did one like that. I did one like that. I could have done one like this. Right? That's an ellipse too. And I told you that this is not a circle template. That is an ellipse template. But it's a what degree, engineers? 75-degree ellipse. What does that mean? How open do you make this, and what is this degree business? Okay, let's do a person looking out there at the record. Now, this is, if we were to look at it like so, we're going to say that would be the record. That's the circle. But we're going to tip it this way, and it's going to look like that to us, correct? Do you remember the protractor? The protractor told us about what? That's 90 degrees, and that's the angles. So that's 45 degrees. And there's 30 and 60 and so on. Can we turn off? Is the fan on that thing? Could you turn that off? Just, there's a little button you go all the way down on. When this character is looking at that flat circle there, if it is tilted at 45 degrees, let's say, and we've got to keep this consistent, That's that record, and it's tilted at an angle like that, a 45-degree angle. What is that person going to see? It's called a 45-degree ellipse, which will be about like somewhere in there like that. I know there's too many lines. There will come a point, will there not? I should have this up at his eye level, or else I should put him across the room. Just imagine me, okay, looking that way. There comes a point where you've got that phonograph record in that position, and what's this character going to see if his eye's right there? He's going to see a straight line. So a straight line is a what degree ellipse? A 0-degree ellipse. What is a circle? A 90-degree ellipse would be a circle. A 75-degree ellipse is going to be close to a circle. What is a little skinny ellipse like that? What? 5-degree ellipse, really thin, 10 degrees. Some ellipses only go to 10 degrees.
Why is it 90 degrees instead of 100?
Because the circle's divided up into 360, remember? Somebody chose that. It wasn't me. Somebody decided to arbitrarily turn it into 360. I wish they would have done it metrically. Pardon?
360, you can divide it to really 360 parts. It's built.
Why not make it 100 parts and make it so it's 25-degree angle like that, and then you can do 0.25 and all that? Well, the metric system didn't work here, which I guess it should have, but that's another subject, and I better not get off onto it. We're talking about ellipses. Here's the thing. If you are looking at this phonograph record and it's tilting like so, and your eye is there and you're looking like so, it's going to turn into elliptical shapes that are specific. If it's tilted at 10 degrees, it will be a specific ellipse that's 10 degrees. You need to know this. You need to know it so you'll understand what all this business is when you see these little numbers on here. And remember, the major axis is that line. The minor axis is the shorter line. Minor, major. That'll become important 2 weeks from now. Now, if we're talking about tilting a circle. We're talking about tilting a flat circle. A record like so, which is helpful if you're drawing a slinky, I guess, that tilts, all the different circles. Or it might be helpful if you're doing a jukebox that's got records that are flipping and tilting. The thing is that most things aren't flat circles. In fact, a long play record was certainly not a flat circle. It was a slice out of a what? A cylinder. And if you looked at them under microscopes, which we did, it's a fascinating thing. The cross-section of a long play vinyl record is not that way with CDs. They're much more uniform. The cross-section of a vinyl record, you can see little hills and valleys. It's a three-dimensional thing. It's not a flat circle. It's a cylinder slice with hills and valleys in it. That clock looks like a circle, but it's part of a cone because it's got some depth to it. So you run into this thing that we aren't dealing with tilted ellipses all the time. What we're dealing with is things like multi-tiered wedding cakes, which means there's a column of ellipses that will open and close according to the horizon line, or axles. There's lots of axles in this room. I mean, you look around, your chairs are constructed out of axles, those lights are. That is that they're going to have round parts. When they're horizontal, they're like an axle. That is, some are to your left and some are to your right, the cross sections. So, I want to move from talking about tilted circles to talking about ellipses and cylinders. What's the first thing we've got to deal with if we're going to do it drawing in perspective? First thing, eye level. Now, if we've got a cylinder in there, if you drive along the 405 into Long Beach, those great big things right about the place where the airport is, great big cylindrical columns, what I'm talking about, made out of kind of wires. They used to be oil. Yeah, somebody said they were oil refineries, so they're empty. I mean, this is like magic oil that just stands. As you're distant from them, They're out there, and they're just kind of like a series of things like this on the horizon. As you get close to them, what happens? There will be one like that. Let's go out of the picture plane to make the point. The top one looks like this to you. And then the next one like so, and the next one like so. And then as they get toward the, eventually, one of them, if there's one at your eye level, is just going to be a straight line. Okay, so you see where your eye level is at when you are looking at a cylinder standing like that. As it goes up, you are looking up into ellipse. So this one might be 5 degrees, 7 degrees, 9 degrees, or 12 degrees. Eventually, you might get up to a 20-degree ellipse. Or if you're getting right up close on it, Kelly, what happens? If you're getting right up close at that thing, you're going to look up into something that's going to go like that, right? Because you're going to get a distortion. You're going to get severe ellipses, right? And you should probably put it in 3-point perspective. Actually, that might be 1-point perspective when you're doing that. Those ellipses are going to get more open toward the top. It happens for the same reason that a box does the same thing. We say there's a horizon line. If you've got, let's just do it in 1 point to make it simple. If you've got a box there, and if you've got another box that's floating like that, and if you had another one up here, let's make sure that it's coming down to that. It's floating up there like that. Do you see how this ellipse is going to be fitting right in there? That's going to be about the same, but this one, it's going to get more open up there. You're looking up into it. The same reason that boxes do that is the reason that ellipses do that. But I mentioned axles. If you just take this board and go like that, you'll see how it happens with axles. If you've got a box, let's do 1-point perspective again for simplicity's sake. If you've got a box that is sitting here like so, and one like that, and if these are true cubes, that cylinder is going to be open like that, right? It fit in there like that, and this one's going to be thinner because it's closer to that. It's more foreshortened. And if there was one that was standing right there, it would just be a straight line. You get the idea? As they go from your left to right, they'll open more. And as they go from top to bottom, above and below your eye level, they'll become more open. The distance that you are from them makes a difference too. But I haven't the time. Miller used to have these painted models of all sorts of stuff like this, and they were great for perspective studies because they were all these columns that went in and out. And the trick is, when you draw those, the trick is find the ellipse anywhere. These were cut out, so they've got ellipses almost built into them. You can see how as they go down, they curve up, and as they go above your eye level, they'll curve down. Now, that does not just affect architecture. It obviously affects big oil refineries and axles. You remember the Rembrandt drawing that I showed you the first night of a woman sitting there, and there was a little study of her head down in the lower corner that we zoomed in on, and I told you it was a coffee can? He had constructed this woman's head out of a shape like a coffee can, which we'll say that's like an MJB can. We'll call that the proportions. Now, you can tilt that coffee can down and get something shaped like that. Or you can tilt that coffee can up and get something shaped like that. There's an ellipse there, and then there's ellipse. It always helps to draw through and know about that ellipse on the other side. When you are drawing a portrait, if you are right straight on them, you can divide this up from widow's peak and then into thirds. That's the brow line, that's the nose line, and you can start to divide things up out of that coffee can. And the thing is, our faces aren't cylindrical. They're sort of a combination of cylinders and boxes. But you'll know that you'll have the same thing go on there. That brow might be a bit straight, but now you're starting to see that we tip down a bit like that, and that means there's a curve that goes like that. Even if this person is frowning, there is a curve like that that they will conform to. And you'll see more of the top of the head. If we're looking up at this character, there will be the brow there, and you will see the under part of the nose there,